Shaktivel.
Good evening, Rajamani sir. Good evening, Rajagopal sir.
Good evening, Shaktivel.
Good evening.
Good evening, everybody.
Good evening, sir.
Good evening, sir. Good evening.
Good evening, sir.
So I'm happy to welcome today's speaker and Ramya madam, and then Palni Kumar sir, chairman of Kanjipuram Local Center, and Dr. Ilango, honorary secretary, Kanjipuram Local Center, and then Madurai S. Rajagopal sir, Madurai chairman, and our council member Rajamani sir and Shaktivel sir, and other Sivadani Pillai, Kanyakumari Local Center chairman and the secretary. Once again, I welcome everybody. Today, we are, I think, fifth day we are doing already that Coimbatore, Erode, other centers, Hosur center are completed. Now today we have Kanjipuram and Kanyakumari local centers are doing today's meeting. On behalf of Kanjipuram local center, Madam Ramya madam is doing going to present one paper, and then on behalf of Kanyakumari local center, Mr. Natarajan going to present today. Going to present. So now I hand over to Ms. Rajagopal to welcome address, sir.
Thank you, Ramdas. Good evening to all our members. It's my pleasure to welcome you all for today's program. Today is the fifth day of our 40th year celebrations. Today, the host is Kanjipuram Local Center. Dr. Palni Kumar, Chairman, and Dr. Ilango, Honorary Secretary. We have to thank them for arranging today's lecture, first lecture. First lecture is smartening of vandalized structure. Speaker is Engineer K. Ramya, Civil HOD, Sri Sai Ram Institute of Technology. And the second lecture is 6:30 p.m. hosted by Kanyakumari Local Center. Engineer Sivadani Pillai and Engineer Marudu Perumal are arranging this second session. Today's second session is rehabilitation of dams. Technical session by Engineer S. Natarajan, retired Chief Engineer, PWD, Tamil Nadu. I welcome you all once again. Thank you.
I welcome Dr. Palni Kumar sir, give the felicitation address and then continue, sir. So Dr. Palni Kumar sir.
Good evening to one and all present here. Thank you very much for the opportunity given us to host the lecture on behalf of Kanjipuram Local Center. I warm welcome
Yes, sir.
Mr.
And
Ramdas,
message on
TNSC.
chat இருக்கு இந்த அத கொஞ்சம் படிச்சுக்கலாம். இவரு
Okay sir, முடிக்கிட்டு சார் முடிக்கிட்டு.
felicitation முடிஞ்சதுக்கு அப்புறம்.
Rajagopal sir, Madurai Local Center Chairman, Secretary, Madurai Local Center, and Rajamani sir, Shaktivel sir, and the Chairman, Swadhana Pillai, Kanyakumari Local Center, and also from Madurai Local Center Chairman is here, and many other secretaries, and our Secretary Ilango Devarajan, and Mrs. K. Ramya from Sri Sai Ram Institute of Technology, all our beloved members. This is a very great opportunity to interact on this 40th year celebration of Madurai Local Center. So Madurai Local Center have created an impression in the history. So they have gone through the very long years. Now they have reached to the 40 years of existence. When you are comparing with this, we are like a child, you are like a mother. நாங்க தமிழ்ல சொல்ல போனா அப்படின்னா எங்களுக்கு 3 வயசு தான் ஆகுது. 40 இயர்ஸ் இருக்கிறவங்களை வாழ்த்துறதுக்கு எங்களுக்கு வயது இல்லை. ஆகையால் வணங்குகிறோம். On behalf of Kanjivaram Local Center, we are giving very high appreciation and other things to the Madurai Local Center. Previously, they have hosted the council meeting in a very good manner. Now, they have reached to the 40 years and the 40 years celebration is going on. 40th
40th year,
year.
sir.
Yes, sir. Yes, sir.
40th year celebration is going on. This is a very great opportunity to serve the engineering community. So this is a great opportunity for us also to interact with the engineering community. So that this is a very great sense of service to the humanity and social service for the engineering people. I wish Wonderlal very luck. The Madurai Local Center, they must have to continue their aim-on service and they must have to reach 50 years, 100 years, 150 years, 1000 years, 2000 years, like that. So that they must and they have to serve for the people and to the industry and to the education. Thank you very much for the opportunity. This is a very great opportunity for the people to interact. Even we are a small center, you have given the opportunity to host this seminar, for which I express my sincere thanks to one and all for the opportunity given to us. And this kind of service will enhance the interaction between the engineers and the technocrats, so that we are able to know what are the things that are happening in the world, and the people are able to know the things that are happening in the different field of engineering and technology. Thank you very much. Thank you for the opportunity. Thank you.
Thank you, sir. Thank you.
So before introducing the speaker of today,
காஞ்சிபுரம்
Sir,
செக்ரட்டரி பேசுறாரா?
அவர் தான் சார் இன்ட்ரோடியூஸ் பண்ணிக்கிறாரு, அவரே பேசிட்டோம்.
Okay. Thank you for giving opportunity, sir. Respected IEI Chairman Engineer Ramadas sir, and respected Kanjivaram Chairman Dr. Palnikumar sir, and respected Chairman Madurai Local Center Adagopal sir, and then the council members and below my IEI members and others. So welcome you all. So initially our Chairman Dr. Palnikumar sir, he gave a very nice welcome address. So whatever it is, it's correct, and also we are very young. So you are giving opportunity to host one of the presentation here. So I am very proud to introduce today speakers, Engineer Ramya. She is graduated year 2005 in Anna University. He completed BE Civil Engineering. Later he joined ME Structural Engineering in SRM University. She has joined professor and head in Sri Sairam Institute of Technology. She is having very wide experience in this field. She is having more than 10 years experience in civil engineering field, and also is doing a lot of consultancy work. She is very actively involved in Kanjipuram local chapter. She arranged so many lectures, and also she sent student in so many activities in throughout Tamil Nadu. So she is one of the very active participants, and also is mingled with our Kanjipuram local chapter. So in this small introduction about Ma'am Ramya, so I am inviting to present today lecture, the smartening of vandalized structures. So I think now, ma'am, you are going to present your lecture, ma'am.
Okay, sir. Thank you. Thank you for the introduction, sir. So first, a very big salute to Madurai local chapter, IEI local chapter. So my age is very less, so it's my age will be your experience. And thank you for giving me this opportunity to present my findings with you, share with you. Thank you, sir. So let me start my presentation. And I also thank our local chapter chairman, Dr. Palnikumar sir and the secretary, Dr. Ilangovan, for giving me this opportunity. So let me start. We should never forget from where our bread and butter comes. So I thank Sri Sairam Institute of Technology, where I have learned so many things and it has given me so much of experience about it. So our college is NAC accredited. All the courses are NAC accredited, and we are also NBA accredited. So let me start with my presentation with a small story. It's about an elephant and 6 blind men. So this blind man, they come across an elephant, and they have learnt about the conceptual about what the elephant looks. So when they come across the elephant, they touch in each and every part, and one will touch the trunk and he will say it is very hard, and other will touch the ears and he will say it is very soft. So based on their experience, what they are doing it's correct according to them. So what is the moral of the story is, humans have a tendency to claim absolute truth based on their limited subjective experience, as they ignore other people limited and subjective experience which may be equally true. So each one of them is experienced. So am I audible? Yes. Yes. Okay. So each one of our experience are truly
Louder, please. Louder, please.
okay, sir. Now it's okay, sir.
No, it's somewhat better.
Okay, sir. So each one of the experience also is a truly a true experience. So what the subcontractor says, what the concrete material supplier says, what the construction chemical people says, or everything is true. So the repairing of a structure, spartaning of vandalized structure is nothing but repairing of a damaged structure. So what all the people, they do the inspection, they limit themselves with their experience. So it is required, there's no such courses available in civil engineering for repairing, or any certified program is there. So the civil engineer has to wear the cap of being a qualified engineer who can analyze the NDT test and who can be a specialist also. So why the repair is very, very important? By 2025, the repair industry will be the major industry to contribute most of the economy to the country. In 2016, people are doing all the innovations in the repair industries. They may fail in that, but later on they will achieve it, and the more innovations are coming in the repair industry. So it is very important to know what are the causes of the repairs which is happening in the building, and how we can prevent it, and how we can do the remedial action to it. So what are the considerations of the cracks are there? First, we have to check it out whether it's a structural crack or non-structural crack. So what is the width of the crack, and in which member it has happened, whether the environmental exposure conditions are there, and which type of members it has the crack has been appeared. So these are the consideration should be made to find out the crack. So the major source of cracks are because of the soil movement, thermal expansion, moisture expansion, or others like the structural stability. So before knowing about the cause of the crack, first we should know how to read a crack. So the orientation, location. So in the side I have shown magnifying glass and a scale. We know how to identify the crack. Based on this, we can find out the width of the crack and the orientation of the crack. So first, let me explain about the structural cracks. The structural cracks is purely based on the design and the reinforcements which we are providing it. So in beam, I have categorized some 5 cracks, different types of crack, and column and slab. So these are the pictorial representation of the crack formed. So mostly flexure cracks occur at the end of the beam, and the shear cracks occur at the normally it will be in a 45-degree angle. So in the middle there will be more flexure cracks will be there. There is a hard thumb rule that the stirrups which we are providing at the end of the beam should be closely spaced. In the middle we can increase the spacing. We should never go with the thumb rule, and we should go according to what the design output has come. So most of the site engineers, they follow the thumb rule and they ignore the design factor. When it is ignored, at that time only such kind of cracks are developed. But nowadays we are strict to more standardization and more specific rules. So these cracks are avoided. But coming to the non-structural cracks, this is still not yet avoided. We can see in everywhere. This is because of the temperature change and the moisture variations fully depending upon the environmental conditions. So first we have to classify the cracks. So how the cracks are classified? These are the crack taxonomy. If it's a thin crack, like hair-like structure, we call it as thin crack. And if the crack is between 1 to 2 mm, it is a medium crack. If more than 2 mm, it's a wide crack. And the crazing is about the cracks when they are closely packed. That is called crazing. So this is the pictorial representation of the crack. So I have categorized the crack into 6 categories: plastic settlement, plastic shrinkage, earlier thermal contraction, long-term drying shrinkage, crazing, corrosion of reinforcement, and alkali aggregate reaction. So out of this, the first 5 cracks occur when the concrete is casted within 10 minutes to 7 days. So if we concentrate in this 10 minutes to 7 days period, we can avoid this 5 cracks. So first we'll see how to classify the cracks and how to identify the cracks. So first category is plastic shrinkage crack. We can see here it occurs on the surface of the concrete, and where there is a change in depth, there also the crack appears. So these cracks are called plastic settlement crack because the depth is changing from one point to another point. Next is the plastic shrinkage crack, which occurs from 30 minutes of the concrete caster time to 6 hours. So this we can see it here. It will come in a group. So either it is parallel or perpendicular to the plane. Next is the thermal contraction. It occurs from the day 1 to 3 weeks. The crazing is this, that we can see it pattern. These are not the major issue of it, but it affects the aesthetic look of the structure. So these can be avoided by a proper remedial measure, like while casting itself, and the prevention we are making it, it can be avoided. Next comes the corrosion of reinforcement. You can see here, due to corrosion, the concrete will spell out, and we can see the rods over here. So this can be avoided with a proper thing. Corrosion is a very big topic. I'm going to concentrate on first 5 cracks, which are the major part of the causing the crack. Why I'm saying the corrosion is a very big topic, since India is a subtropical country, we have a various kind of environmental conditions in our country. Most of the major cities are located in the coastal area. So these are the problems which we come across. Normally in this side, it's a high carbonated level, and this side the temperature will be more, the high humidity. At one part the corrosion is totally negligible in the northern side. So because of this, the climatic conditions keep on changing, the corrosion is also being affected. So this topic is a very big topic. Why I'm saying it's a very big topic? Because corrosion damage will lead to the 4 times the cost will be increased. This is based on the study of Tushi Kyosi, who is a Chinese civil engineer. He has analyzed in 1982. He has given a report on it. This type of analysis is only suitable for Indian countries, which will be taken care, since the most of the places are in coastal area. The corrosion damage will increase the cost of the maintenance and the repair of a building. So before going into that, I'm going to tell about only the plastic shrinkage cracks and thermal behavior and shrinkage behavior of a building. So first, let me tell you, these are the 3 major reasons why the cracks are developed. The soil movement. So soil movement is for the settlement of soil or the heave of the clay. This occur when caused by the tree roots or the poor compaction when the building is constructed. At that time when the compaction is very poor, if there is a leak in a plumbing system, it will make the soil more saturated, and this will also disturb the compaction of the soil. Due to this, the failure may occur. And if it is a clay soil, it may expand or contract. Because of that reason also, we can see the crack, and due to poor drainage, the cracks will form. So how to identify these cracks are from soil movement. So if the crack pattern is in a stepped pattern, so this is purely because of the soil movement. When there is an unequal differential settlement between good bearing capacity of soil and poor bearing capacity of soil is there in a foundation, at that time there will be a differential settlement will occur. The crack pattern will be in the form of steps. So by seeing this, we can say, yes, this is because of the soil settlement, the crack has developed. Not only this pattern, we can also see a crack pattern, which is the crack which is parallel to the floor. This is also and due to the movement of soil. And this can be stopped by using a underpinning technique or underpiling technique, and we can use precast piles to erect it in the soil to increase the strength of the soil. So by seeing this crack pattern, we can say that this is because of the soil movement. Next is the very important, and due to the stepped crack, it also lead to the horizontal crack which is in the inward displacement. So this you can see here, the step pattern, and from the plinth beam is also affected. So because of the step, there is always an inward displacement will be there. So total wall will get collapsed. Next comes the thermal behavior. This photo which I have taken, it's from the area Washington. So what here happened is the two slab got bulged up. This is because of the thermal behavior. So whenever when we are casting a concrete in summer, the seasonal temperature also plays an important role. The concrete contracts. When it is placed on the winter, it expands. For example, if we are casting a slab for 100 feet long, if we are casting it in a summer, we have to make a formwork for 100 feet 3 inches, because it increases by 3/4 of its total length. But when we are casting in the winter, we have to place the formwork for 99 feet 9 inches. So I have given the two different temperature norm for in India. We can go with 38 degrees Celsius, so 100 degree Fahrenheit we can take it. This is the climatic conditions which is suitable for our country. So due to this, what happened when there is we don't provide a expansion joint or to concrete to expand. So at that time, this kind of bulge will occur. This is because they did not consider the seasonal temperature. Not only this, the daily temperature also affects the concrete. The concrete may bend in concave or convex because of the day and night. And in another important behavior of concrete is that we have to see that during the curing time, initial time when the concrete is casted, at the initial 1 to 5 days when it is cured, at outer surface temperature will be less, whereas the interior temperature will be more. So this kind of action is called heat of hydration. So what happens? The outer surface it will get cooled, but the inner surface, the heat is retained and it is restrained completely. At that time, what happened? The stress which is developed will be greater than the tensile stress. Because of this only, the thermal cracks occurs. This kind of cycle is called heat of hydration. It is in heat of hydration, because of this heat, the thermal crack occurs. We can control it by using a shaved ice during the mixing of concrete, or we can put ice in the water and then take that water and use it for making a concrete, or we can use admixtures like fly ash, or we can cast the concrete in the blocks, or we can use low heat cement. So this is the very important factor. So in our places like where the temperature is very high, we advise the site engineers to use ice while casting a concrete. They can slice the ice and put it in the water, and after that sometimes they can take that water and they can use it for making a concrete. So second is the third is the shrinkage behavior of concrete, which is very important. The shrinkage occurs when there is a rapid loss of water from the surface of concrete. It has been said that when a 50 kg of bag of cement is used to make a concrete, it almost requires 20 liters of water. But out of that 20 liters, 12 liters of water get evaporated while making a concrete itself. So, and it is also said that, like Mr. R.K. Raina, he said that when concrete is cast, almost 1 liter of water get evaporated from 1 square meter of concrete area. So, this evaporation we cannot avoid it, but we can reduce the rate of evaporation, and we can retard it so that to increase the shrinkage behavior of concrete. So how we can avoid that? We can use the plastic sheets over there after casting, after the initial setting of normally the cement, the concrete will set within a half an hour. After that, we can cover it with a plastic sheet in order to stop the evaporation. And it is also important to stop the bleeding of the concrete by using a proper formwork. So this is very, very important. So this is a research paper which has correlated the three important factors. One is the curing temperature, the seasonal temperature, and another is the concrete strength and the the number of days we are curing the concrete. So when for us, we almost 105 degree Fahrenheit we can take, it will come around 102 degree Fahrenheit. When it is 55 degree Fahrenheit in Western countries, we can cure only for 43% is enough. That is, for example, if we are in a slab is curing days of 14 days, we can reduce it by 7 days in the Western countries, because the climatic condition is going to help, and it is going to increase the strength by 110%. So this is another thing is that here in our country, we have to cure it, start the curing from the day one, not day, instead of saying day one, within the half an hour of initial setting of the concrete. If we start curing from that day onwards, that time onwards, our strength can attain only up to 82% of it. So the seasonal temperature plays a major role here while curing, and we cannot fix it like we have to cure it only for 14 days, 21 days, like that. So we have to keep on curing it for as long as it is possible in order to increase the strength of the concrete. So how the curing can be done? There are two types of curing. One is external curing and another one is internal curing. In external curing, as we all know, the water curing, water ponding, water spraying, and fog mist and all. We can also use some kind of sealant over there. We can paint it over the outer surface of it. And we can also use the chemicals like pulverized rubber, polyethylene films to seal the concrete at the top surface, and the plastic sheet can also be used. When we use the polyester films, it will act as a curing membrane over it, and it will retard the rate of evaporation. Internal curing can also be done by mixing a chemical over it, or internal chemicals we can add it, pulverized rubber, and we can use lightweight aggregate and super absorbing polymers, water saturated weights, and the wood derivatives which can used as a internal curing. So by using such kind of curing method, we can completely eradicate the cracks. So because of the improper curing only, the basic 5 cracks occurs. So that if we take care of it, these non-structural cracks can be prevented, and the aesthetic look of the concrete can be increased. So this is SP34. I know everyone knows about it, but we don't study in our academics while working. I worked in Octave India Private Limited, which is a German-based company, and it's a detailing company. What we and the Germans have in common, the codes are almost similar, and we have a 12-meter rod length and they have a 14-meter of rod length. So what is the major strength of it? That they will not leave in a single rod without an anchoring or lap. If a bar is there, its two end is there, either the two end will be anchored, or one end anchor and one end will be lapped. So each rod, even the slab rod, they will bend it. So I'll just want to show you about this at the end of the session. I think it's not opening. So it is visible, sir? Sir? Sir, my screen is visible?
Hello, slide is okay, but have you opened your PDF file?
Yeah, yes, sir. I have opened it, sir.
Just you come out from the இதை விட்டுட்டு நீங்க அந்த ஸ்கிரீனை ஷேர் பண்ணணும், PDF ஃபைல ஷேர் பண்ணணும்.
PDF தான் சார் நான் ஷேர் பண்ணிருக்கேன், தெரியலையா சார் அது?
But no, we are not seeing that.
Okay sir, 1 minute sir, 1
It's
minute.
not visible.
Sir, now?
Okay, now it's okay.
Yeah, yes sir. So the bending, the detail about this book is a handbook each civil engineer should have. We can tell our students to have about it. While bending a rod, it will increase the strength of the rod by 70%. Even a small 90-degree bend will increase. So this is not followed as a practice in a site. Even for the slabs and all, they will not do it. I just want to show you about one small opening reinforcement detail. So if there is an opening, rectangular opening is there, the additional reinforcement should be provided. So all the information, the reinforcement detail, first layer, second layer, all the layer detail and all is given in this code book. So this is the hand code book for everything. Even it has also given about the crank positions where it has to be given and the lap distance. So this will avoid the structural crack. And apart from the loading position, what mistakes the site engineers do, for example, in a site, if there is no 25 mm dia rod is not present, what they will do, they will use 216 mm dia rod instead of 125 mm dia rod. But in Germany, what they will do, if 25 mm dia rod is not there, they will stop the work, they will wait for until the material arrives. But in India, we'll put 216 mm dia rod, we'll adjust the work, and we will not check about the lap and anchorage about it, and we proceed the work and we'll complete it. So because of the small problem, there may sometimes most of the time there will not be any crack will be appearing, but sometimes due to the proper anchorage length problem, at that time the problem may occur by causing a cracks over it. So this is the SP34. I think everyone should have it. Most of them since will be having this. So this I'll share it to you, sir. So next, I'll come to my PPT. So these are the two. First, I have discussed what are the types of cracks are available, structural, non-structural. What are the types of cracks, and then how to avoid the cracks and how to identify the cracks. Now I'm going to tell you about how we can do the remedial measures. Smartening means nothing but repairing of the crack. Either we can use the member sealant coating, or we can stitch it, or we can use the waterproofing thing and the surface preparation, grounding or by injecting cracks, and underpinning, and column jacketing and beam jacketing. So I'll show you a video where the people had used their innovation idea and made it as a product, and now they are selling it. So repair industry, as I said earlier, it is going to be a very big boom industry where we can use our innovations and bring out the new solution of it. So I'll show you a video about an Australian company.
Construction process of structural perfusion adhesive. Remove surface coating until concrete surface appear. Make it clear and sound. Grinding surface smooth and chamfer angles.
Madam, you put a little bit increase your volume.
Okay, sir.
Repair and level concrete defects with force repairing adhesive.
Now, sir, it's clear, sir?
Okay.
According to the drawing. Grind and roughen adhering surface of angle bar and batten plate. Install gasket. Clamp steel skeleton with special fixtures. Leave 2 to 3 millimeters gap between steel skeleton and original member. Weld batten plate and steel skeleton. Weld should be straight, uniform, no virtual welding, leakage welding. Embed injection nozzle and exhaust hole according to design. Seal gaps between angle bars and batten plates with horse crack repair adhesive. After crack repair adhesive is cured, test pressure with air, and if there is leak, seal it in time. Mix the horse structural perfusion adhesive according to the ratio. Mix and stir evenly. Avoid bubbles. Do not mix too much adhesive once to avoid waste. Inject horse perfusion adhesive via injection nozzles with low pressure. Stop injecting when the adhesive appears in the near exhaust hole. Seal the exhaust hole and keep injecting adhesive with low pressure for 10 mins. After adhesive is cured, remove injection devices and extra adhesive. 72 hours curing and maintenance time is needed after injection construction. Check if there is hollowness after adhesive is cured. Finally, apply anti-corruption and anti-fire coating. Horse Construction, high-end structural strengthening material specialist.
So this is column jacketing. So this is the another one. So these are the different types of remedial measures, and so since the time is running out, I'm just skipping the videos. So these are which are the problems are there, and it can be rectified using this kind of material. Fiber reinforced concrete is a very big gift for us. We can repair all the over consolidated and consolidated concrete, and honey, for improper curing, we can use this fiber reinforced polymer to strengthen it. If there is any dislocation, like improper location of reinforcement, we can cover it up with a beam jacketing or column jacketing. So what I want to conclude in this is that the errors which are caused by it, it's not the cracks, or the error which I'm calling it's crack. It's because of improper implementation, site implementation. If it is taken care properly, the cracks can be completely eradicated. Not only it is the responsibility of a design engineers to take care of it, it is also a responsibility of site engineers to do it all the works properly. The first foremost important thing, if they do curing itself, that itself is enough. And it is not necessary we should go for high strength concretes like M40, M50. It's not required. If it's a 3-story building, M25 itself is sufficient for us, and we can do wonders with the M25 itself. If it is a very complicated structure, at that time we can go for M40, and we should have a sufficient knowledge about how to execute it and how to place the reinforcements and all. So there is a handbook available on cracks. I think everyone will be knowing it, and you can go through it. So thank you for giving me this opportunity. Thank you. Sir?
1 minute, madam. Madam, today I think you've given the excellent presentation.
Yes,
right now, actually, IEI Tamil Nadu State Center having one same type of problem. I'll show you some photographs to you.
okay,
And
sir.
just you go through that and then give your comments and.
Sure, sir. Sure, sir.
1 minute.
Yes.
I'll show the photograph. Visible that?
Yes, sir.
Actually, in IE building, we have one basement floor.
Okay, sir.
This is a steps.
Okay, sir.
All the beams are cracked actually.
Is it, sir? All the beams, sir?
Yeah,
I can see the reinforcement also, sir.
this one.
Yes, sir.
See.
Yes, sir. Yes, sir. So totally, it's because of corrosion, sir. The cover
Corrosion.
they have given, yeah, they have given the cover very less over there. This we can rectify it, sir. We can apply the sealant and all. Only it's only corrosion effect, sir, not because of a major problem. It's a corrosion effect. It has to be taken care, sir.
Okay. So still this work is pending. Maybe before my tenure, I think you will complete and then close it.
Okay, sir.
Thank you.
Okay, sir. Thank you, sir.
Ramdas sir,
Yes, sir.
Ravichandran, good evening.
Solung, sir. Good evening, sir. Good evening,
Already
sir.
visited in person during our meeting.
Yes,
It is
sir.
due to the corrosion as well as the water that is to be used during the construction consists of a salt contamination.
Okay.
In this reason, there is a water contamination that made the corrosion.
Another one thing, that building is nearer to sea, sir. That is also the problem.
Sir?
Sea erosion also there because our building is nearer to sea.
Because that is going to be exposed to the atmospheric air, the corrosion and spalling of the concrete, it accelerates the corrosion again. Hence, there is a problem, there is a distress in structures. It is to be repaired, it is possible to repair, but to be carried out as early as possible. Otherwise, we say it is a concrete cancer.
Yes, sir.
Okay.
Good evening, sir. Ravichandran, sir, is my professor.
Good evening, Ramya. Good evening, Ramya. Otherwise, we say it is a concrete cancer, sir.
Okay.
Okay, sir. Okay, sir.
As soon as possible, we'll do it.
Yeah.
Okay, sir. Okay, sir.
Okay.
Thank
Can
Thank you, madam.
good or not?
Thank you, sir.
Sir,
Good
Rajamani,
presentation,
sir.
Ramya.
You
Sir,
can
thank you, sir.
go through the chat, and is there any question you can see?
Yes, sir. Yes.
Ramdas,
Yes, sir.
you can open the chat box.
Madam,
Yes,
I am Kumar. I have
Yes,
one
sir.
question.
Yes,
Hello.
sir. Yes, sir. Tell me, sir.
Regarding the mosaic tiles,
Yes, sir.
mosaic tiles in the
Yeah,
house
yes, sir.
flooring,
Yes, sir.
it is a lifting in the center. Between
Oh,
the
yes, sir.
joints,
Yes, sir.
it is raising upside.
Sir, it is parallel to the foundation or perpendicular to the foundation, sir?
All in the floor itself. It will be all directions.
Sir, I think it is because of the soil movement only, I think.
No, only the
Ramya,
Yes, sir.
Ramya, madam.
Yes,
Kumar,
sir.
sir. Kumar, sir, can I
Yes, sir.
interrupt?
Please.
Yes.
No problem.
Because that is during the time of laying of the tiles, the bottom there is air voids or presence in the mortar. Because of the mortar, if the room is locked a long time, the air inside the air warm up. Because of the temperature increase, the air presence in the voids below the tiles is also increased. So it is to be increase in the value. If there is a gap is available, it is escape. Otherwise, there is a internal pressure is developed there and the tiles are lifted up. Not only that, sometimes you can see in earlier days in the home and all, they are just after cooking and all, they are going to be putting the rice and all over the floor. At the time, it's going down. There is that time also there is a crack. Or ironing continuously in a floor. They are providing the bed sheet and ironing at the bottom, the floor level itself. There also continuously happen. There is a side crack. There is a cracks between wall and the edges of the floor also happen. It is because of increase in temperature. The increase in temperature increase the volume of the air that is to be present in the mortar laid below the tiles. So it is lifting up. Sometimes the tiles are not only smaller amount, it may be burst and the tiles are lifted and hit on the floor also.
Actually, sir said mosaic, sir, because mosaic.
Not mosaic. Not mosaic.
Oh,
this style is
ceramic
tiles. Ceramic tiles. Sorry.
Mosaic with a long-term effect.
Yes.
Okay, sir.
Ceramic tiles only.
Okay.
How to minimize it?
how to minimize. Sir, you can provide the mortar in a better way without air voids.
It is happened second time also. That is why.
Because that is a layman thing, sir. Because the mortar without air voids.
No, after laying the mortar, you have to compact well. You can avoid this type of thing. So that's what earlier days they used for compaction. They're using special type of material. So you can remove entire air, then the problem will be solved. Actually, it happened only in the terrace. If you are compared to the inside the houses, it normally it happened in terrace. Even the poor workmanship also one of the main factor for this one.
Okay, sir. Thank you.
Sir, here one point I want to make. The recent chemicals we are using for the house cleaning, that is damaging the joint joints in the tiles, and this allows the air to go in and lifting the tiles.
No, sir. This is easily you can avoid. That is in between the that is tiles. If joint will be wider, again you can refill it using with the help of the white cement. If you are not take care about using white cement, whatever the problem you said, you definitely you have to face it. Normally it happen in bathroom side, because in bathroom side they are used for acids and other strong chemicals they are going to use. Usually what happens, the crack will be widened. So the rest of the floors, suppose first floor means, second floor means, first floor the seepage will be there, especially the bathroom and toilet. You can see that. So what you have to do is, instead of removing entire tiles, you put the white cement, then you can finish it. Actually, if it is happened, if you put it in every once in 2 years or 3 years, you can properly you can maintain the bathroom and toilet. The seepage will be can avoid.
Yeah, this is what the contractor was telling me, but within 1 year it developed, and this is what irritating us actually.
This is happened poor workmanship, sir. This is a purely in poor workmanship. If it is happened like that, you don't give the paisa to concerned person. You check it. You pour the.
They got everything.
After 1 year only it will surface, you know.
No, actually it happened in my house also, but once in 2 years I do this type of things only. Because if you are maintaining hygienic, you can't avoid. Otherwise, we have to compromise. Don't use any chemicals in this over the tiles.
Actually, our engineer was telling 2 reasons. One, as you said, the acids they are using in the bathroom for cleaning. That is the main reason. Another reason is, if they started washing their clothes, you know, in the bathroom itself, this type of things will be aggravated. So
washing the cloth is not a problem. Using the acid, even if you are going to be using the acid with a high concentration, then this problem will occur whatever the material are going. Because we are also a human being, we are also having a tolerance limit. So like that, the material also there is a tolerance limit.
Sir, you quoted one thing, that is washing cloth. Sometimes என்ன பண்றாங்கனாக்கா துணி வந்து அடிச்சு துவைப்பாங்க. புரியுதுங்களா? அந்த மாதிரி அடிச்சு துவைக்கும் போது என்ன ஆகும், ஜாயிண்ட் ஆட்டோமேட்டிக்கா டிஸ்டர்ப் ஆகுது வாய்ப்பு.
நம்ம வந்து வாட்டர் சீப்பேஜுக்கு தான் அது அனலைஸ் பண்ணோம். அப்பதான் தெரிஞ்சது இந்த ப்ராப்ளம்
இருக்குன்னு. அது ஒயிட் சிமெண்ட் போட்டுறலாம் சார். நார்மலா என்ன பண்ணுவாங்க, கம்ப்ளீட்டா எல்லா டைல்ஸை எடுத்துட்டு ரீலே பண்ணுவாங்க. அது அன்னெசரி காஸ்ட் அது. So நம்ம just refill white cement போட்டு நல்லா டைட்டா பேக் பண்ணாக்கா you can erase that type of.
There is another one, sealant also available, sir. You can use the sealant in the joints, so it will be avoided.
Okay, any other questions, sir? So thank you, ma'am. Today you have given the excellent presentation. I think a good topic and all those things. Now we move to the next presentation. Now I invite Sivadanupillai sir. Sir, Sivadanupillai sir.
You are a guy.
Sivadanupillai sir.
சிவதானு காணும். முத்தம்பெருமாள்
இருக்காரு.
அவரை ஸ்டார்ட் பண்ண சொல்லுங்க, அவரை இன்ட்ரோடியூஸ் பண்ண சொல்லுங்க. நெக்ஸ்ட் கெஸ்ட்
சார் முத்தம்பெருமாள் சார்.
அன்மியூட் பண்ண சொல்லுங்க சார்.
அவர் மைக் அன்மியூட் பண்ண சொல்லுங்க.
அவரு அன்மியூட் பண்ணிக்கலாம்.
முத்தம்பெருமாள்.
எஸ் சார், எஸ் அன்மியூட் பண்ணிட்டேன் சார்.
அதான் உங்க சேர்மனை காணோம்.
சேர்மன் ஆமா சார் காணல, ஏதோ நெட்வொர்க் ப்ராப்ளம் தெரியல.
சரி, நீங்க வந்து
சார் ஓகே சார், தேங்க்யூ சார்.
நீங்க இன்ட்ரோடியூஸ்
சார்
பண்ணிருங்க.
குட் ஓகே சார். myself I am Muthamperumal, retired assistant executive engineer TNEB, now honorary secretary of Kanyakumari local center. Sir, good evening to all the participants of this 5th day of 40th year celebration of Madurai local center, sir. On behalf of IEI Kanyakumari local center, I convey my thanks to the chairman, secretary of Tamil Nadu State Center, the chairman and the secretary of Madurai local center, and our former chief engineer, TNEB engineer Rajamani sir, now the council member of IEI, for arranging this mega serial. Sir, forever, we would like to mention the full support given by the Madurai center, like financial support, administration support, like how to form the office, how to elect the chairman, secretary, and the committee members, and other correspondence to be made with the headquarters. At that time, any doubt arise, we have contacted engineer Rajamani sir and cleared the issues by him. So I have conveyed my heartiest thanks to engineer Rajamani sir for assisting us in softly, friendly, and gracefully. Till now, he supported our team. Thank you, sir. Sir, next session will be going to engineer S. Natarajan. Today's technical program on the topic rehabilitation of dams will be delivered by engineer S. Natarajan. He's an eminent engineer. He is now a committee member of our Kanyakumari local center. Sir, I submit the biodata of engineer S. Natarajan. S. Natarajan graduated from NSS College of Engineering, Palakkad, Kerala, and took his master's degree in structural engineering from Video Engineering College, Calicut. He joined in Tamil Nadu Public Works Department as assistant engineer in 1982 and worked in various capacities before retiring as special chief engineer in 2015. During his career, he was involved in a number of major irrigation projects for which investigation, design, plan formation, and estimation was supervised by him. He is a recipient of Honorable Chief Minister's Anna Award for Best R&D Engineer in Irrigation Wing in 1996. He has got membership in various professional bodies such as Fellow and Chartered Engineer of IEI also. Member in Indian Water Resource Society. Member in Indian Society of Technical Education. He got his MBA, Human Resource, degree in 2007. He has also worked as Under Secretary on Deputation in Central Board of Irrigation and Power, New Delhi. Sir, thank you, sir. Next session shall be handed over to engineer S. Natarajan, sir. Sir? Hello, sir?
Yes, sir.
Sir, Natarajan, sir?
Yes, sir. Yes, sir.
Sir, please
Yes.
take over the session, sir.
Thank you, sir. Thank you for introduction, our Honorable Secretary. Good evening to one and all. I'm extremely happy to be associated with the 40th year celebration of IEI Madurai Local Center. In fact, I had my AMI membership. In fact, I had my AMI membership as early as in 1982 from Madurai Local Center only, immediately after joining the department. For the past 4 days, we had excellent lectures from Padma Shri Dr. Mailswamy Annadurai and from various local centers on energy conservation, 3D printing, superconductor, aircraft mobile, ad hoc network, and today smartening of the vandalized structure. So I am also today going to have our topic on civil engineering, a rehabilitation dam, in particular to Mullaperiyar Dam, the estuary in Madurai district, presently in Theni district. I visited some close relatives who were hospitalized. I was running here after there. Only very limited time I got. So I am giving a small extempore lecture only. As all of us know, India is an agrarian country for which water is the main source of production. So human survival depends on the agriculture. For water storage, we go for construction of dams. As such, these dams play a vital role in our economic, in the development of our nation. So India, as we know, India ranks 4th in the world after China, USA, and Russia in terms of number of dams. In India, most of the dams are owned by respective states, but there are some few other organizations, namely Bakras Bias Management Board, Damodar Valley Corporation, NTPC, NHPC. They also construct, own, and operate their own dams. The safety of the dams can be threatened by natural phenomena such as flood, earthquake, landslide, and deterioration of construction materials. The safe design of a dam is a major consideration in constructing a new dam or rehabilitating an existing one. A safe dam is one which performs its intended functions without imposing unacceptable risk to the public and society by its presence. In this context, we can analyze Mullaperiyar Dam. So in 1979, in Kerala Assembly, people's representative made a very huge cry, saying that Mullaperiyar Dam is going to burst, based on a leading Malayalam paper report. That paper reported that dam is a very old one and joints are peeled off, and in some area there are a huge holes. Even an elephant can go and stay inside, something like that. At that time, Kerala Chief Minister was Honorable Mr. Muhammad Koya, and in Tamil Nadu, our Honorable CM was Dr. M.G. Ramachandran. They immediately asked our Central Water Commission, which is the nodal agency for all the irrigation projects in our India, to study and to give a report. Now we will go back to a small history of the Mullaperiyar Dam. So during the fag end of 16th century and the early part of the 17th century, throughout India faced a severe drought. At the same time, the erstwhile Travancore area, the present Kerala state, which is on the western side of the Western Ghats, was receiving nearly 3,000 mm of annual rainfall. So our King Sethupathi of erstwhile Ramnad district made an investigation in as early as in 1808 to see that to divert the west flowing water to eastern side so that that water can be brought down to Madurai, the present Madurai, Dindukal, Ramnad, and Sivaganga districts. So, but they actually succeeded in investigation. Their main problem was, the main constraint was the money. So actually they couldn't continue the problem. Then after British people came to India and the matter was put forth to them, after a series of investigation, finally in 1882, a proposal was made by British engineers for about rupees 63 lakhs. After the proposal was approved by Royal Engineers of Britain, the work was commenced in 1887. And with a number of hindrances, the construction was completed in 1895. So at that construction, Mullaperiyar Dam was the largest masonry dam in the world. This is a gravity dam on Periyar River, located at about 2,900 feet above MLC on the Western Ghat in the present Kumuli village of Pyramid Taluk of Idukki district in Kerala. John Pennicook was the chief architect of the project. Even before the construction, an agreement was drawn between then Madras Presidency and the then Travancore state for 999 years to utilize the water by the Madras Presidency. The lease deed was signed on 29th October 1886 between Government of His Highness Maharaja of Travancore and Right Honorable Secretary of State of India in Council. One of the conditions stipulated was all the lands which will be submerged about 8,000 acres and further land required for construction with the water proposed to be diverted be granted to British government on an annual lease amount of rupees 40,000 British rupees payable to them to the Travancore government. Even now, Tamil Nadu government is paying the 40,000 rupees to state of Kerala. So Lord Kanimara, by cutting a tree at the site, started the project in 1887, and on completion, His Excellency Wenlock, then Governor of Madras Presidency, inaugurated the project on 10th October 1895. So this is the 125th year of Periyar Dam. So in the history of the Periyar project written by A.T. Mackenzie, the then executive engineer of Madras PWD, in 1898 itself, he has told that for a large dam such as Periyar Dam, the seepage is allowable. So, but comparatively, Periyar Dam could be taken as remarkably watertight. After the completion, height of the dam was 152 feet. It was 12 feet wide on the top, and the capacity of the dam was 443 million cubic meter. So just the bottom width of the foundation was 150 feet. Just to compare the structure, this was actually constructed with the technical know-how existed in 1890s. We had recently some 50 years back, after 50 kilometers downstream this Mullaperiyar Dam, Kerala State Electricity Board constructed one of the biggest arch dams in Asia, the so-called Idiki Dam. You know, the height of the dam is 555 feet, but the base width is only 55 feet, because it is an arch dam for which the forces are applied only on the sides. No, there is the actual weight is not coming down to earth. Actually, the definition of the Idiki Dam is it is a thin, double curvature, hyperparabolic shell. Actually, if you are standing on the downstream side of the Idiki Dam, and if it is heavy raining, you won't get wet, because it will be acting as an umbrella over your head, because the dam is bent on both sides. It is like this and it is like this. So even you won't get a drop of water over your head. It is designed like that. Because of arch dam only, arch effect only, they were able to construct such a huge dam with a small base width. Here, even though our dam was height of 156 feet, our base width was 142 feet width. So after construction, the reservoir level exceeded. The high FRL fixed was 152 feet. The reservoir level exceeded 152 three times in 1924, 1943, and in 1961. The structure withstood all these floods. Only in 1908, actually, these 10 wells were provided for surplus. Originally, in the dam, there was no spillway. After constructing 20 years only, they constructed some spillway provision made by the adjacent of the earthen area, constructing 10 additional vents. That will discharge nearly 86,000 cusecs. The dam was in the heavy, thick forest and stood majestically. And after 84 years, in 1989, the paper news came, Mullaperiyar Dam is going to burst. So at this juncture only, Dr. K.C. Thomas, the then chairman Central Water Commission, along with the Tamil Nadu government official and Kerala government official, personally inspected the dam on 23/11/1979. And in the statement he made in the crowded press meet at the Tekadi at the dam site itself was, the dam is safe and there is no need for panic. Then on 25/11/79, this expert committee met at Thiruvananthapuram and had made analysis of all the pros and cons, and they came with 3 objectives. The dam we should go for on emergency measure, then on medium-term measure, and then on long-term measure. In emergency measure, they told that shutter of the spillway to be raised fully to lower the reservoir level to 136 feet. So immediately this work was done within 1 month, and we brought down the water level to 136 feet by 17/12/1979. The another item instructed was to provide a reinforced concrete capping after knocking off 1 meter from top of the dam and widening the dam 12 feet to 21 feet. Then the next step, to provide additional spillway in case of emergency. If there is some extra flood is coming, we should be prepared to pass that extra flood also. So we have to provide additional spillway. This is the emergency measure. In medium-term measure, the Central Water Commission suggested the possibility of strengthening the dam by providing cable anchoring by the assistance and by the guidance of Central Water Commission. In long-term measure, it was decided to go for providing RCC backing. So now back to emergency measure. After depleting the dam to 136 feet immediately within 1 month, RCC capping work has been taken up. This set of work was first time taken in India, and nowhere in India this type of was done. So we had a close contact with the Central Commission, and all the designs and to be approved by Kerala State LC, Kerala government, and then to be vetted by Central Water Commission, and then to execute the work. Was heavy first concrete of 1:2:4 was laid with the provision of 2 small rooms also protruded towards the reservoir for providing automated water level recorder in future. Providing RCC capping work was extended beyond 2 to 3 feet on upstream side, both up to 145 feet elevation and 6 feet on the downstreams of up to 125 elevation. The work was completed in 1980-81 with great difficulty because at that time there was no power, no quarters for engineers to stay, no approach road to dam site. Only approach is 14 kilometers. You have to travel from Thekadi by boat. Otherwise, you have to walk 5 kilometers from Vallakadavu through the thick forest to the dam site. Up to Vallakadavu, you can reach by our jeep. From Thekadi to Kumli, Kumli to Vandiperiyar, Vandiperiyar to Vallakadavu. It comes nearly 50 kilometers. Then after very difficulty, Kerala State LC Board provided the power connection to the dam site. Then only they started the work and completed this work. Then for providing additional spillway, probable maximum flood was calculated. That is the flood which may occur once in 10,000 years. Nowadays, Central Water Commission insists for all major dams to consider this aspect. For smaller dams, they will go for SPF, Standard Project Flood Provided Flood, which is a flood which may occur once in 100 years. So with the help of flood hydrology director, because previously we have not done such analysis and there was no experience for our field engineers and as well as our engineers in our chief engineer's office. So there was mutual close contact with the Central Water Commission, and with the help of the flood hydrology directorate of Central Water Commission, we finally decided the probable maximum flood. The one constraint we came across was the Idiki Dam, which was constructed 50 kilometers below the Mullaperiyar Dam, was designed for a spillway capacity of 1,22,000. So it was decided to provide additional 3 radial gates to surplus 36,000 in addition to already provided 10 additional spillway which are able to pass 86,000 cusacks. With various objections from Forest Department and Kerala government, the work was completed in 1990. Then regarding medium measure, that is cable anchoring, Messrs. Sim India Bombay, one company, did the work and completed in 1981. In this, 95 holes were drilled at the 9 feet away from upstream face. One set of cable means 34 numbers of 7 mm rod. The cable was placed up to 40 meters below the parent rock. Bottom 20 feet was connected with concrete. Then each cable pre-stretched by applying a load of 120 ton and locked. Then the cable above the dam was cut so that a load will be applied on the dam by pre-stressing force so that the dam will sit down. The force will act towards the earth so that the dam won't over-topple. This work was also completed by the end of 1981. After these 2 works only, I joined in the department in March 1982 as assistant engineer, and my first posting was at Mullaperiyar Dam. Then as a part of the long-term measure, providing RCC backing concrete was preferred instead of buttressing as previously done in Bandradara Dam as well as in Pechipar Dam in our own Kanyakumari district. The Central Water Commission went for, we should provide without any doubt, without any fear to the public, we should go for full length of backing concrete to the existing dam, as it is a very old dam of nearly 100 years old at that time. So the designs were revolved, got concurred from Kerala government and got vetted from Central Water Commission. Work was started by the end of 1982 and completed in 1994 May, after a long 12 years, because this was practically a new dam was constructed. Initially, a single tender was called for a total height of 145 feet. At that time, the bidder quoted extraordinary higher rate, and it was decided to split up the work. That is from 0 to 75 feet, and then 75 to 145. Work from 0 to 75 was completed by June 1986. And for the second part, though the estimate was sanctioned in 1885-86, work could be started only by April 1989, and work dragged on till May 1994. Actually, this is the major work we had done at Mullaperia Dam, the backing of the main dam. So practically a new dam was constructed, considering the bottom width of the new providing backing concrete was nearly, it varied from 40 feet to 55 feet as per the site condition. And one of the things suggested by Central Water Commission was the new concrete proposed or to be laid with the old masonry dam, which is uncourse rubble masonry, should be laid in such a way that one course of the old rubble masonry should be removed and the new rich thick of concrete should be placed. So while execution, we find it very difficult to remove one course of the rubble masonry throughout the face of the downstream. So we represented to our chief engineer, they came with another proposal. You need not take a full course of the rubble masonry. Instead, you fully sandblast the area, apply thick mortar, then add the new concrete, which is richest mix 1:2.4:3.34, a design mix evolved by our soil mechanics laboratory under the AC design control. So this richest mix was butted along with the concrete, along with the old masonry. We used to say it is a butting concrete. Then the backing concrete was, of course, a lean mix 1:4.83:6.71 with a temperature reinforcement. As previously lecturer Dr. Ramya Madam told that unless we provide this temperature reinforcement, there is all the possibility for crack to be formed, as the area is exposed to sun always. So we provide a skin reinforcement over the entire area of the upstream face of the new dam also. So actually, before laying this concrete, we made the foundation by drilling. In the foundation also, we made a grouting so that any minor cracks in the foundation can be grouted. So we used this this hexagonal pattern of concrete. So by the one thing I should forget, the entire length of the dam was 1,200 feet, was divided into 45 feet of 20 blocks. Actually, we need to do the work for 900 feet only. So there were 20 blocks, and all the 20 blocks were exclusively joined with a bituminous pad, so that each block will act at a separate individuality. So we prayed also this copper sealant as a joined, otherwise bituminous pad was also provided. Then, so as this dam was constructed some 100 years back, there was no drainage gallery to see the seepage. But earlier, our great man McKenzie told that though this dam was considered to be very minimal seepage, there was some seepage, and subsequently after construction, the dam was grouted, and once observed 0.20 cusics of seepage was brought down to 0.06 cusics, and it stood up to more than for 20 years. It doesn't vary. it was very, very within the permissible limit only. So in order to study the seepage further, we provided 2 drainage galleries also in the new dam structure, one at a 10 feet elevation and another at 45 feet elevation. In that dam gallery also, we have constructed some drainage holes to the major original dam so that any seepage water will seep through it and will be collected in the small drainage portion of the drainage gallery, so that we can calculate what is the drainage outcome, what is the seepage outcome using the normal V-notch and everything. So one of the major difficulties we found that actually the 20 blocks was divided into 10 blocks of each, and 2 subdivision was doing this execution work. One subdivision was coming from one end and the other was coming from other end. So actually we were to join this gallery in a straight way. So with the limited, the dummy level we had at that time, that and theodolite which was available with us at that time, we made an excellent work. Even then, sometimes there was a slight inclination of the gallery. Finally, we took out somehow adjusted, and it was in a somewhat straight line. So many times our chief engineer had came and scolded we people. You people are not employing the alignment and properly, and I got so many scoldings. All these things only for the betterment of the work. Professor Dr. Mohanagasan, he was the chief engineer at that time. He is a very versatile irrigation engineer who recently passed away. He was the man in charge. He was the total, actually he was in charge of so many dams in Tamil Nadu. He was in charge of Satanur, Krishnagiri, Manimuttar and Bhavani Dam, Bhavani Sagar, Amravati. In so many dams he had worked, and he had worked as a professor emeritus in College of Engineering, Guindy, and he is a well-known engineer in North India side also, because as right in my biodata, he told that I worked as Undersecretary in Central Board of Irrigation Power. At New Delhi, the only non-chief engineer from Tamil Nadu is Dr. Mohanagasan only. In so many meetings, I used to suggest his name, and he used to come there for our meeting, and he will also I had a code relation with the Professor Dr. Mohanagasan also. So actually, on my promotion as executive engineer from Nagarkoil, I opted so many divisions. But Mohanagasan was the chairman of Kaveri Technical Cell, and he drawn me to the Kaveri Technical Cell and was appointed as a member in Kaveri Technical Cell, because he previously I had worked in Periyar Dam, and so he personally drafted me to Kaveri Technical Cell also. So coming to our point, this also to receive the seepage, we had provided no fine concrete, and also provided GI pipes and everything to be grouted after many years along the downstream of the backing concrete. So all these works were done with the limited because in 1980 we had a very limited engineering. Even then we had not used that batching plant. There we are supposed to go for some 2,000-2,500 meter cube concrete. The contractor laid only 18 to 20 meter cube per day with the limited resources available, because he faced so many labor problems in Kerala. As it is in Kerala state, the contractor was forced to draw some 50% of Kerala labor, and he was having his own labor from Erode area. So all these people used to have, these Kerala people will work correctly except to the time. So the work was dragged, and finally all the work was completed in 1994 only. After simultaneously, when the backing concrete was done, construction of additional one was taken up, and work was completed in January 1988. And thereafter, radial shutters was installed and work completed by 1990. In addition, operation of lift shutters in the existing surplus regulator, which was manually operated, was converted into electrical with the necessary modification, and this work was also completed by all respected in 1995. Similarly, there was a small dam about 50 meters adjacent to main dam. We used to call it as a baby dam. So detailed structural design and drawing were prepared for government of Tamil Nadu for providing RCC backing for that dam also on the same line as done for main dam. But till date, work could not be started since government of Kerala objected with so many unwanted dissent. The then chairman Central Water Commission opined that all the items of work advised to be carried out in the high-level meeting in 25/11/79 would be completed and the dam will be rejuvenated. It will be as good as a new dam which can serve for another 100 years. Since all the work have been completed, Government of Tamil Nadu requested for raising the water level from 136 to 142 feet. But Kerala government never agreed and opposed it. Then Government of Tamil Nadu approached the Supreme Court for the justice. As instructed by the Supreme Court, an expert committee under Dr. Mittal was formed to study the safety aspects of the dam. The expert committee in March 2001 recommended that water level could be raised initially from 136 to 142 feet. And after completing the strengthening measures of baby dam, possibility of raising water level from 146 to 152 feet could be reviewed. Government India filed this report before the Supreme Court with a strong recommendation. Supreme Court gave its final verdict on 27/2/2006 and permitted Government of Tamil Nadu to raise the water from 136 to 142 feet and to carry out the remaining works as on the original dam to the baby dam, and Government of Kerala should not object and should cooperate with all the works to be carried out. At that time, Kerala government passed a Kerala Irrigation and Water Conservation Act in Kerala Assembly in March 2006, stating that Kerala government has got full power to operate and the Mullaperiyar Dam, which Government of Tamil Nadu disagreed and again went for justice in Supreme Court. Finally, after so many sittings, and even when I was in Kaveri Technical Cell, I had also attended 2-3 sittings of Supreme Court in connection with the Periyar Dam with our chairman Monushan sir. And finally, Supreme Court also insisted that Tamil Nadu government can go for 136 to 142 feet. Finally, during the period of Dr. Jayalalitha's regime, we reached in 2012 and 2015, 2018 and 2019, we rose up to 142 feet. Finally, before concluding, I should say that the dam designed and built by Colonel Pennycook 125 years ago, braving heavy odds at a time when no dam of similar features existed elsewhere in the world, has fulfilled in abundant measures the objective and the planners and the builders. It has worked to the economic development of the entire region which it was meant for. The engineers who have maintained and strengthened this structure are confident that it will continue to shower immeasurable benefit on the people of that region for many more decades to come. In fact, actual similar work we are doing in Pechipare Dam in Kanyakumari district also. Only recently we had completed Pechipare Dam also. There was no drainage gallery. After construction of Mullaperiyar Dam in 1895, Pechipare Dam was completed in 1995. At that time also, there is no drainage gallery was provided in the dam. This time also, we had provided a drainage gallery for inspection, and all the works were completed except small works in the additional spillway. So this is a good model of good rehabilitation of existing dam, which we are supposed to carry if required, because all the area we had already harnessed. There is no new place to construct new dams anywhere in Tamil Nadu, a small check dams or a small. Otherwise, nowadays we are going for interlinking of works, which we had as superintending engineer and special chief engineer. I was personally involved in Athikkadu Avinashi scheme, then Metur high level canal work, then Satanur Nedungal level. All these works are in Tamil Nadu government's self project, and already Athikkadu Avinashi scheme work has already completed. Nearly 30% work of completed, And recently, our Honorable CM who visited Coimbatore has announced that the work will be completed by December 2021, so that those drought-prone area of Avinasi and Attikada area will be having more water, so that they can go for high irrigation, and this drain and this borewell will be recharged, and this will be a very useful work. That cost of the scheme is 1652 crores, and already nearly 30% of the works are over. So if we have to go for strengthening of the dams, this is the way we have to do all the work, and we have to maintain our old structures. As I already told, there is no new works, no new area to investigate and to go for construction of new dams. So by this, I just conclude. I thank our chairman to give me opportunity to present with this small topic. I'm very sorry I couldn't provide with any PowerPoint with a lack of time. Otherwise, I should have given more details. All these drawings are available. And even as an assistant engineer, I collected my chief engineer's office the original investigation copy of the drawing signed by Colonel Pennycook is available with me only. Because actually, many people, this Ramba, Ella Karayan Ariche, or Ramba in the record room, they were thrown away. And once fine morning, we were asked to clean that room. So when I entered that room and searched, I got this drawing. And I personally, I got an always affiliation to Mullaperia Dam, because I studied in Kerala, and my first appointment was as a Tamil Nadu engineer was in Mullaperia, and I was always attached with Mullaperia Dam, and I used to have all the paper cuttings of Mullaperia Dam with me, and I thought this Colonel J. Pennycook, whose signature as an autograph, I am still keeping it with me, and actually you can see the old buildings. Our PWD building, then the Madras Presidency College, all the Nizam buildings, all the drawings are available in our drawing, because all those were the old, our PWD working building is the old Nizam building, Hyderabad Nizam building. When our the PWD building, as you know, it is a very old department started in 1857 itself. So all the records were there, and many records were demolished by ants. So we were asked to preserve some drawings. So all the building drawings were preserved, and these drawings nobody were interested. So actually I thought I will keep it with myself, and I am having that drawings also. So I once again thank Madurai Local Center for giving me an opportunity to share my small views on technical session regarding this rehabilitation of dams. And I pray this Madurai Local Center will grow and grow day by day and achieve a glory, unimaginable glory in coming years also. Thank you, sir.
Thank you, sir. Narayan, sir. You have given the excellent, I think you are sharing entire your experience today, I think.
Thank you, sir.
Most of the participants know about that Mullai Periyar Dam and all those things. Thank you, one and all. Do you have any questions? The participants can allow to ask any question. Themselves are unmuted and then ask the question.
I'm Raju Gopal.
Yes, sir.
Mr. Narajan.
Yes, sir.
This is not for Mullai Periyar. This is Vaigai Dam. You know, in Vaigai Dam,
yes,
more than 30 feet of slush is accumulated.
Yes.
Which reduces the capacity of the dam.
Capacity, yes.
Is there any possibility for removing this slush?
Only way is we have to dredge. But generally, if it is in a forest area, forest people won't allow. Because actually in Pechipare Dam also, we put up a proposal to our government. So here also, there was the gross storage was reduced to nearly 30%.
Yes, sir. Go ahead.
Hello. No, sir. Connection is sir. So meantime, Sivadana Pillai sir, just felicitate
Yes,
and
sir, yes, sir.
okay.
For a small time, I will take. Due to my problem in the net, I can't be in time in the meeting. Sorry for
No
that.
problem.
Sir, respected Ramdas sir, respected Rajagopal sir, respected Narayanasamy sir, respected Rajamani sir, respected Kannan sir, respected Muthambermal sir, and the keynote speaker, Engineer Nadarajan sir, and the committee members and all the members, my warm welcome to you all first. Today on MLC's, that is Madurai Local Center's 40th anniversary, we are here to felicitate. On behalf of KKLC, Kanyakumari Local Center, I convey my best wishes to Madurai Local Center and its members. In this occasion, we wish to convey our special thanks to Dr. Rajamani, Engineer Ponpadi, and Engineer Vijay Kumar, who are the main engineers in the formation of Kanyakumari Local Center. நேரம் ரொம்ப குறைவா இருக்கனால ஒரு சிறிய வாழ்த்துப்பாவுடன் என்னுடைய வாழ்த்தை முடித்துக் கொள்ளலாம் நினைக்கிறேன். அகவை 40 வாழ்த்துகின்றோம் மதுரை உள்ளூர் மையத்தை அம்மாவென்று. அகவை 40 வாழ்த்துகின்றோம் மதுரை உள்ளூர் மையத்தை அம்மாவென்று. ஆம், அம்மா குமரி மையம் எங்களுக்கு மதுரை மையம். ஆம், அம்மா குமரி மையம் எங்களுக்கு மதுரை மையம். இதயத்தின் உள்ளிருந்து ஒலிக்கும் வார்த்தைகள் இது. இதயத்தின் உள்ளிருந்து ஒலிக்கும் வார்த்தைகள் இது. ஈன்ற தாய் குமரி மையத்திற்கு மதுரை மையம் என்று. ஈன்ற தாய் குமரி மையத்திற்கு மதுரை மையம் என்று. உச்சத்தை இந்திய மையங்களில் இருமுறை ஈட்டிய மையம். உச்சத்தை இந்திய மையங்களில் இருமுறை ஈட்டிய மையம். ஊக்கத்தை எங்களுக்கு ஊட்டிய மையம். ஊக்கத்தை எங்களுக்கு ஊட்டிய மையம். எங்கும் புகழ்பரப்பி நிற்கும் மையம். எங்கும் புகழ்பரப்பி நிற்கும் மையம். ஏற்றம் பல கண்ட ஏற்றமிகு மையம் மதுரை மையம். ஏற்றம் பல கண்ட ஏற்றமிகு மையம் மதுரை மையம். ஐயமில்லை ஆண்டோர் அனைவரின் உழைப்பிலும் உயர்ந்த மையம். ஐயமில்லை ஆண்டோர் அனைவரின் உழைப்பிலும் உயர்ந்த மையம். ஒன்றுபட்ட உழைப்பில் ஒளிரும் மையம். ஒன்றுபட்ட உழைப்பில் உயரும் மையம். ஓங்கி சொல்வேன் மதுரையே, ஓங்கி சொல்வேன் மதுரையே, உனக்கு நிகர் நீயே என்று. அவுடதம் பிற மையங்களுக்கு நீயே என்றும். அவுடதம் பிற மையங்களுக்கு நீயே என்று. அக்தே குமரி தரும் மனம் நிறைந்த வாழ்த்துக்கள் மதுரைக்கு. அக்தே குமரி தரும் மனம் நிறைந்த வாழ்த்துக்கள் மதுரைக்கு. நன்றி, வணக்கம்.
Actually,
சிவதான பிள்ளை புலவர் சிவதான பிள்ளை அவர்களுக்கு நன்றி.
Kanyakumari Local Center is one of the baby of Madurai Local Center.
ஆமா.
Previously, Kanyakumari and Tirunelveli attached with Madurai Local Center.
And Thuthukudi also.
Thuthukudi also later on, first Thuthukudi comes out, and then Kanyakumari and Tirunelveli 4-5 years before, I think. 4 years before.
மிஸ்டர் சிவதான பிள்ளை, நீங்க அற்புதமான ஒரு கவிதை எழுதி மதுரை சென்ற வாழ்த்து. நீங்க அதுக்கு ரொம்ப நன்றி.
ரொம்ப நன்றி சார், ரொம்ப நன்றி.
ரொம்ப நன்றி. நானும் திருவனந்தபுரத்துக்காரன் தான், அதனால நீங்க மலையாளத்துல கூட பேசலாம்.
சரி சார், சரி சார்.
ஓகே, ஐ விஷ் கன்னியாகுமரி சென்டர் grows much and you have a lot of engineers from மகேந்திரகிரி. மகேந்திரகிரியில் இருக்கவங்க எல்லாம் சேருங்க, அவங்க எல்லாம் வருவாங்க, நிறைய பேர் சேருவாங்க.
ஓகே ஓகே ஓகே, இருக்காங்க சார், நம்பர் இருக்காங்க.
அப்படியா, ரொம்ப சந்தோஷம். நான் மகேந்திரகிரி
ஃபோன் நம்பர் ஒன்னு கொடுங்க சார்.
Kanyakumari is one of the active center now.
சிவதான பிள்ளை சார்.
சார்,
மகேந்திரகிரி திருநெல்வேலி டிஸ்ட்ரிக்ட்ல வருது.
ஆமா, திருநெல்வேலி டிஸ்ட்ரிக்ட் சார். இல்ல, கன்னியாகுமரி பார்டர் திருநெல்வேலி. கன்னியாகுமரியில இருந்து அங்க வேலை பாக்குறாங்க சார்.
கன்னியாகுமரி ரெசிடென்ஸ் அட்ரஸ் கொடுத்தவங்க எல்லாம் கன்னியாகுமரி சென்டருக்கு வந்துருவாங்க. ஆபீஸ் அட்ரஸ் கொடுத்துறவங்க எல்லாம் திருநெல்வேலி சென்டருக்கு போயிருவாங்க.
ராஜாமணி சார், மகேந்திரகிரியில வந்து ஒரு கேட்டு திருநெல்வேலி, அடுத்த கேட்டு கன்னியாகுமரி. மகேந்திரகிரியுடைய குவார்டர்ஸ் வந்து பனகுடியில, அது வந்து திருநெல்வேலி. Whereas மகேந்திரகிரியுடைய இன்னொரு குவார்டர்ஸ் வந்து நாகர்கோவிலுக்குள்ள பொன்னப்பநாடார் காலனில. So that belongs to Kanyakumari. So Mr. Narayan,
that is called, yes sir.
நல்ல very cogent, நல்ல cleaner நீங்க explain பண்ணீங்க about.
Thank you sir.
Any work is done on Manimuttar Pavanasam Dam, Manimuttar Dam?
Manimuttar Dam, actually we have done only upstream phase treatment. In order, because as you know, Manimuttar was experiencing very heavy leakage. Inside the gallery, we had a small well. Unless the motor is operated, the well will overflow and the water from the downstream will go upstream in a large quantity. So always there are some people are appointed to see that motor is running properly. Always it is running. So when we came across, when this World Bank project came into Tamil Nadu, we put this problem to our World Bank mission, and they suggested to go for upstream treatment. So the upstream phase of the dam was raked. All the joints were raked out, and we inserted some chemical. That work was done by Bombay company. We called for the tender, and they have done. And now the nearly, because that work was done in stage by stage. When the water level recedes, we will do the work. Then again when recedes, we will do the work. Stage by stage, they have completed the work. And when the analysis of the seepage was done, the seepage was considerably reduced. Otherwise, before doing this work started from 1996, our IHH Pune, we got a model studies at hydraulics and hydrology at Pune. They came with a report that more than 50% of the dam cement used in the dam was already been washed out with as a calcareous material with the seepage water. So there was an alarm situation that that dam will also collapse. But as in Kerala, there was no such a heavy report. This was only between our engineers only. So this problem we put up to the World Bank team, and they suggested this we should go for, we need to go for only upstream treatment, because already there is a long gallery inside the dam, so that we can monitor the seepage. So we went for this upstream phase treatment, and we had seen that the seepage has considerably reduced.
But the last 2-3 years, it is not going beyond 80 feet height.
Last year we reached 119 feet, sir. The top level is water 120. Last year we reached 120 feet, sir. Manimuttar Dam also reached 120 feet.
80 feet மேல போறதுலன்னு ஒரு apprehension இருக்கு, அதனால தான் கேட்டேன்.
இல்ல.
Now they are going.
Yes, sir.
Because Kalakad is famous, the forest region.
Yes, sir. Mundandurai, Kalakad, Mundandurai.
Wildlife sanctuary.
Yes, wildlife sanctuary.
And very difficult to control that. Okay, good. Yes. Very good. Nalla presentation, sir. Thank you.
Thank you, sir. Thank you, sir.
Good.
Ramdas, sir.
1 minute, sir. Actually, everybody knows that. Yeah.
Ramdas, sir.
சொல்லுங்க சார்.
இந்த ஒரு இவரோட அந்த பையனை கொஞ்சம் பேச சொல்லுங்களேன்.
கிருஷ்ணா, what is the name?
சக்கரபாணி சாரோட grandson.
Hello.
Sir, good evening, sir. My name is Krishna Prashant.
Yeah, okay, sir. Okay, sir. You share your this thing, sir.
Sir, I am grandson of Sri late engineer K. Chakrapani. He's a retired chief engineer in Twat Board, and he's a former chairman in Institution of Engineers during the year 1990 to 92, sir, if I remember correctly. He passed away yesterday due to coronavirus, yesterday by morning, sir. And I wanted to attend this event on behalf of just a fond remembrance of my grandfather, because he was preparing for the speech very dedicatedly, which was supposed to be held on 19th. And I express my gratitude all morning to his sudden demise. I believe few of you must have known about my grandfather and how he has been actively working till this time. His age is 94 running, sir. And I would confidently say that more than his personal life, he was so much dedicated and passionate in all his professional activities, including Institution of Engineers. He lived it to to it till his last breath. இது எப்படி சொல்றேன்னாக்கா, இப்போ I was moved to tears seeing him giving that prepared speech that he prepared, which he was invited to do on 19th. He was doing that unconsciously in his deathbed at a hospital, sir. Me and my cousin who was taking care of my grandfather at hospital at GH, he was giving his speech unknowingly, unconsciously he was giving. Even at his partially unconscious state, he couldn't recognize me or my cousin, who happened to be his grandsons. But he tried to acknowledge when I said some random name of his close associate from Pensioners Association. He's also working actively in Madurai Pensioners Association, Madipa. He did feel that his profession is also a part of his family. Truly, his loss can't be replaced, neither by us or by the professional associates who are closely known to grandfather. I am proud to be born as his grandson, and I live trying to be like him at least. I thank all of those who has been closely associated with my grandfather, my tata, both personally and professionally. And thanks a lot for being a part of his loving memories, sir. If anybody knows my grandfather personally, I look forward to hear from them as well. Thank you, sir.
Thank you, Krishna. I only come to your house on 9th for recording his speech. So we have recorded his speech. It is available at IEI, but we could not execute it on the day of that inaugural session. No. So we are greatly obliged to him throughout his life. He has been with us. He is being with us. He is always with us. Thank you for your speech.
Sir, I request you to share the audio file.
Sure,
If possible, I would contact you, sir.
So our honorary secretary has gone on leave. It is available with him. I will give it to you after he is coming.
Okay, sir. Okay, sir. Thank you, sir. Thank you so much.
Thank you so much for sharing with us.
Krishna, if you send your email ID and phone number, maybe we'll ask him to send it to you.
Sure,
Just
sir.
you type it in the chat. I will arrange for that.
Okay, sir. So I'm also a member. I'm also a member in Association of Engineers, sir. I'm presently doing PhD at IIT Tirupati, Andhra Pradesh.
Okay, fantastic, fantastic. Fantastic.
I belong to civil engineering profession, basically, and from environmental engineering. Apde tata avada vali da coincidental ah illaya theriyala enakku. I just came with same field.
So kindly share our condolences with your family members on behalf of IEI.
Sure, sir. Thank you. Thank you so much, sir. Thank you.
Thank you, Krishna. And then now, sir,
what of
Rajamani sir,
Shaktivel.
Close pannilama.
Close pannirunga. What of thanks by Mr. Shaktivel.
So now, formal vote of thanks given by Shaktivel. Sir, Shaktivel sir.
Yes, sir. Good evening, gentlemen, and today's sessions, both the sessions were very, very useful to the people, also who were interested in the civil and especially on the dams and the structures, you know. And really, I am very much observing the necessity of these two topics in the day-to-day life. I thank Tamil Nadu State Center, Ramdas sir and his colleagues. I thank our chairman, Mr. Rajagopal, and also I thank our advisor and the council member, Dr. Rajamani. I also thank our Kanjipuram local center who participated and whose chairman has given us a very good lecture on the strengthening of dams, strengthening of structures, how the cracks develops, and it's very knowledgeable actually. And I thank personally for the detailed presentation also. I also thank our Dr. Palnikumar for his comments, and also our Kanyakumari local center for the participation, for the felicitation, as well as their committed presentation by Mr. Nadarajan. Even though Mr. Nadarajan was telling that he has not prepared the presentation for that, but you know, this is a very sensitive subject, and everybody was keen to listen what the experienced engineer is delivering, and he has not missed even a small detail of how the inspection teams went for doing the initial inspection, what are the hurdles they faced in the maintenance, etc. Also, the questions answered by him is also very valuable about the mud clearances and collection, and also about the down south Manimutare dams and all. And really, we are very thankful for the audience. Today's the number of audience also, it is more than 20% increase. Thanks to Tamil Nadu State Center Chairman and also his colleagues, and also our Honorary Secretary who is missing today because of his personal commitments. Both of them and also Mr. Rajamani, who also conducted many people, the attendance is increased. And thank you very much for audience for your commitment and being very active in going through the subject, also by asking the questions to Madam Ramya, who the first presenter and also the second presenter. Thank you all for facilitating this event to conduct like this on the 5th day of our 40th anniversary celebration. Thank you so much. Thank you to everybody.
Sir, next day we are having a very good lectures from Neyveli Center and the Katangulathur Local Center. I request all of you to kindly participate and get the benefit out of it. Thank you so much for giving the opportunity for Madurai Local Center to serve you. Thank you, Mr. Ramdas.
Thank you, sir. Thank you, sir.
Thank you, Mr. Ramdas.
Thank you, Ramdas.
Thank you,
Thank
sir.
you.